This video will show you how to graph a nominal by nominal interaction. Here is my data set. My dependent variable is total engagement in the classroom, and my independent variables are student male and target groups. I've already made dummy variables for these. So whenever time a student is male, they have a 1, and if they're a female, they get a 0. Every time they're in the targeted group, they get a 1. Otherwise, if they're in the control group, they get a 0. And I want to know if their amount of engagement of males depends on whether they are in the targeted group. In order to do that, I made a male by group interaction by simply multiplying male by group together. So let's go ahead and run the regression. Reset. Find my dependent variable, total engagement. Put in my independent variables, target male, target group. I'll also control for praise. That has already been set to it as a continuous variable, so how much praise a student gets. I'll put that in block 1. And I'll put the interaction term, the male by group interaction, into block 2. Paste. Find the code. Run it. Look at the output. Look at the R squared between Model 1 and Model 2. Model 1 has all the variables in it but the interaction, and Model 2 has all the variables and the interaction, and R squared doesn't change at all. So this is probably a good indication that the interaction isn't contributing much to the model. Let's scroll down to the coefficients. Here's Model 1, which is all the main effects of student gender male, group equals target, and the centered praise variable. That's Model 1. And Model 2 has all those same variables, but has the interaction term as well. Notice the p-value for the interaction is 0.69. This means the interaction is not significant. It does not appear that it depends on whether I'm male and whether I have in the group, the target group or the control group. Notice also the p-value for the student gender equals male is 0.31 versus while in the previous model it is 0.077. You cannot trust the p-values of your parent variables in the presence of an interaction. That's why the book suggests to always go back to Model 1 if the interaction is not significant, which is what you would do in real life. For sake of argument, we're going to pretend that the interaction term really was significant, and I will show you how to graph it. Here is an easy way. You left click onto the coefficients block, and you right click and say export. In the type, you want to find my Excel 2007 and higher micro enabled. You want to browse to figure out where you want to put this new Excel sheet. I'm going to put it in my Stats 2 course interactions folder. I'll call this a group by male interaction graph just started. Click save. Then click OK. You cannot paste this one, does not allow you to, and then you can click on this nice little box here. It will open the containing folder, which will save you the step. So click OK. SPSS will think of it in a minute. And it will open the folder. I guess oh, there it is. So I just made this new interaction, or new Excel spreadsheet called group_male_interaction group just started. So I'll double click on that to open it up, and look at this. SPSS has nicely put all the numbers in my Excel spreadsheet, which I've just lost. There it is. Oh, there it is. It really wants to collapse on me. And so all the numbers are already exported. I'm only interested in Model 2 because I'm pretending that the interaction is significant so I can graph it. So how do I graph this interaction? In order to graph this interaction, I need to choose 4 points, or 4 predicted values. The 4 predicted values depend on my gender. The 2 values that gender can take on are going to be male and female, and group. The 2 values that group can take on is target, when group equals 1, and control, when group equals 0. I'll also put those numbers there. So male corresponds to a 1, female corresponds to a 0, target corresponds to a 1, controller corresponds to a 0. And I'll write, for illustration purposes, the regression equation in Excel. So I have engagement is equal to beta naught, that's that number right there, the 92.8792, plus beta 1 times male, that's at negative 2.4, plus beta 2 times group, that's at negative 17, plus the interaction term, plus beta 3, which is the praise. Notice that was just a variable that I was controlling for. It was not involved in the interaction, but it is still involved in the model, so I still have to account for it. So beta 3 times praise plus beta 4 times the interaction term, which is going to be male times group. Okay, so what am I going to do with this praise thing? I don't want to have to, I want this to be as simple as possible. I want this to go away if I can. Well, thankfully, I have centered my praise variable with a mean of 0 before I put in my model. And so if I do that, I can set praise to 0 in my model. So I'm only be considering the children who have a mean level of praise. Let me make a note of that. This interaction is for those students who have a 0 or mean value for praise. If I do that, this praise term, I actually plug in the number 0 here, and this whole term vanishes. So let me rewrite the equation without that praise term. It was beta naught plus beta 1 times male plus beta 2 times group plus beta 3 times male times group. I guess I should be consistent and still call that beta 4 because beta 3 has gone away. All right, so now I want to predict the amount of engagement for a male in the target group, and I can do that in Excel by using the equation function. So I put in equals, and I want to plug in this equation as close as possible. So I want to plug in beta naught. I don't want to plug in the actual later beta naught. I want to plug in the value that corresponds to the intercept, which is 92.879. So I just click on the cell, and then I'm going to put dollar signs around the C and the 8 to hold that cell constant, plus beta 1 male. So the beta 1 is right there, so I'm going to click there, put little dollar signs to hold those constant, times the value for male in this column in column I. The value for column I is going to be male, so when male is equal to 1. So I'll plug that value in there. And for this one, I only want to hold the row constant. I want the column to vary, and that will become clear why in a subsequent step. So I have the beta times male times the value for male, plus the beta times target, so we're up to beta 2, times, so I'll put dollar signs around those because I want to hold those constant across all 4 of my values here, times the value for target, which in this case, in this row, in row 16, is 1. So I want to hold the column constant now, instead of the row. Plus, and now I can just skip praise entirely because I've defined my interaction for those who have a mean level of praise, and that's what's commonly done. So I'll skip that beta 3 altogether and go directly to beta 4, put dollar signs around the C and the 12, and then multiply it by both the value for group, which is 1, so again, hold the column constant, not the row, times the value for gender. And so hold the row constant and not the column. All right, and let's see if that makes sense. This is predicted value. So if I'm a male and I'm in group 1, I'm going to have a constant of 92.879. That's the beta naught. Let's actually write it out. So this is going to be 92.879 plus this beta here, this beta 1 times the number 1, so it's actually going to be minus 2.4, plus the value of times group times 1, so that's going to be minus 17.35, plus this negative value times 1 times 1, so it's going to be simply minus 1.369. So look at that. So I did some rounding errors, but within rounding error, that is the correct value. Now I can just drag this down to get the other predicted value. Now, does this make sense? So I'm still highlighting all the coefficients because I put dollar signs around the appropriate places, but now instead of having gender is equal to 1 and group equals 1, gender is equal to 1 and group is equal to 0. And so what happens in that case? Well, I still have the constant, so it's 92.879. And a male is still equal to 1, so that term is still there, minus 2.4. But what happens to the next term? Group equals target does not equals 1 anymore, it equals 0. So that term vanishes, so plus 0. And what about this one? In this case, I have my coefficient times male times group. My coefficient times male is 1, and group is times 0, so that term vanishes as well. So plus 0 plus 0. And I get, well, if I put an equal sign, I'll actually do the calculation, 90.479. So my calculations are indeed correct. Let's left click and drag this over here and drag it down. Look at that. Let's just double check this one. So this is when you are in the control group and you're female. What's your score then? That's going to be equal to the intercept, 879, plus, well, my gender is equal to male is 0, so that term vanishes. My gender is equal to target is equal to 0, so that term vanishes. And my interaction term is going to be this beta 4, this negative 1.369 times male, which is 0, times group, which is 0. So that term vanishes. And lo and behold, I get exactly 92.879. So this is the constant is the predicted value for those who are female in the control group and who have a mean level of praise, just like the intercept always is. So I have my numbers here, my predicted little matrix here, and I want to make this a graph. I go to Insert. I go to Line Plot. I get this little line plot here. I'll drag this down. I select Data. I'll just bring up this little GUI, and I will drag all of my matrix into that GUI. Click OK. And I have my chart. Now I just need to clean it up. I'll click Add Chart Elements. I'll add the legend. I'll also add axis titles. The axis title on the x-axis is gender. On the y-axis is engagement. The chart title is, I've thankfully written it right above it, is the interaction. Plot for gender by group on engagement for those who have a 0 mean level of praise. Let's move this over. Oh, very nicely formatted. And let's look at this graph. So, if I want to have the highest engagement, I want to be in the control group, that's this red line, and to be female. See how female is slightly above it. If I want the lowest engagement, then I want to be in the target group and be male. So there are slight differences. It does depend a little. But remember this p-value of 0.691 shows that these differences could easily have happened by chance alone. So this graph shows an ordinal interaction, but it's a non-significant interaction. And so there's not much more to talk about.